I welcome you back all. In the previous lessons, we looked at
the periodic table, the periodic properties, whereby we started the first periodic property as the atomic radius. We looked at what is atomic radius. After knowing what atomic radius is, we looked at the various factors that affect the atomic radius. What makes the atomic radius to increase, or what makes the atomic radius to decrease, whereby we have the nuclear charge and then the screening effect. From there, we looked at the variation of atomic radius across the period, where we defined the period as the horizontal arrangement of elements. Now we are going to look at the variation down the group, variation down the group, variation down the group. And using the knowledge that we saw from variation across the period. So if across the period you are saying that nuclear charge is increasing, what about when we move down the group? Because moving down is the opposite of horizontal. That automatically means that moving down the group, the atomic radius increases. The atomic radius does what? Increases. Whereas moving across the period, the atomic radius decreases. And why is it that we are having atomic radius increase as we move down the group? Let's first write the atomic radius increases as increases down the group. Let's take an example. We are having sodium here. We have here potassium. We have here lithium.
Really? It should be 3 plus
8, yeah. We have lithium, we have sodium, and then we have, this one is in period 2, period 3, period 4. Lithium is in period 2, sodium is in period 3, and then potassium is in period 4. Let's look at what happens. Lithium only has 3 electrons. Sodium only has 11, and potassium only has 9. So literally what is happening, we are having an addition of a full energy level, an addition of a full shell. If our lithium is, if this is the nucleus, in lithium we are only having these 2. Then in sodium, if this is the nucleus, we have the first one which takes 2, the next one which takes 2, the next one which takes 2p6. Oh, let me write it properly.
the nucleus. 1, 2, 3. One, 2, 3, 4, 5.
Because when you get 19 minus 11, you get 8. 11 minus 3, you get 8. And we said that a whole shell from O level contains 80 electrons. So in each of the elements, or in each of the atoms, we are adding a full shell. That means a full energy level. If we were at 3, then we are going to 4. If we were at 2, then we are going to 3. So adding a full shell brings about increase in the screening effect. You find that the inner electrons are pushing away the outer electrons. such that the attraction the nucleus has for the outer electrons has reduced. Yes, down the group we both have the screening effect increasing and the nuclear charge increasing. However, the increase in screening effect is too much or is more, and it ends up outweighing the increase in nuclear charge, and the nuclear charge ends up being inevitable, bringing about the increase in the atomic radius. So writing that down, the atomic radius increases down the group because there is addition of energy level, because another would be kind of a repetition. Addition of energy level. For example, you find that in lithium we had 2 energy levels. In sodium we are now at 3, and in potassium we are now at 4. So adding an energy level, what does it bring? It brings, which increases both the screening effect and the nuclear charge. Both the screening effect and the nuclear charge. Both the screening effect and the nuclear charge, they do what? They increase. However, we know that nuclear charge is the addition of electrons. But here we are still having only 1 electron in the outermost shell, which means we have only added the shell, we have not increased on the number of electrons in that shell. That means that the screening effect will increase and the nuclear charge will kind of decrease. But the increase in screening effect is too much or outweighs the increase in the nuclear charge. So which means the nuclear charge ceases or stops affecting the atomic radius, and then we majorly have the screening effect, the one affecting the atomic radius. And why does the screening effect affect the atomic radius such that it increases? I said because there is addition of another energy level, or addition of what we call a shell. And those electrons in the outermost shell will be lightly attracted to the nucleus. As a result, we defined this screening effect. We saw what screening effect is. So we have the example of such variation. It is in group 1. Example of such variation is group 1, the downward arrangement of elements. And we have the element, and then we have the atomic radius, and we have the atomic radius. And our first element in the group of group 1, we only have lithium whose atomic radius is 0.123. Then we go to sodium, whose atomic radius is 0.157. Then we go to our potassium, whose atomic radius is 0.203. We go to rubium, whose atomic radius is 0.216. And finally,
That should be, is it scandium?
which is 0.235. So as you can see, we are seeing that lithium has the smallest atomic radius, and sodium follows, potassium follows, rubium follows, and this one follows. So you find if this has 3, this one has 11, this one has 18, this one has 26, this one has 34. Addition of 80 electrons, and 8 electrons is a full energy shell. That means this one only has, we saw this had 3, this had 2, this has 3, this has 4, this has 5, this has 6 shells. So those shells, the more you add on the shells, the more you increase the screening effect. And we say that screening effect is the tendency of inner electrons shielding off attraction of the nucleus for the outermost electrons. And that would end up bringing about the increase in the atomic radius down the group. And also this one, there is a possibility of you being asked to draw it on a graph. To draw it where? On a graph. We always plot atomic radius against atomic number. And we say that atomic number, that is the number of protons present in the nucleus of an atom of an element. And we know that the number of protons is equal to the number of electrons. So when you're given a number of electrons, then you automatically know the number of protons present in the nucleus of an atom of an element. Let's look at the ionic radius. The ionic radius